Okay, ladies, gents, girls, boys and others, here we go again with another calculation. What we're going to do today is go through a bond energy calculation. These can usually get you anywhere between 3 up to 5 marks. This one is worth 4 marks. Now, as always with calculations, everyone sets these out differently. There is no right or wrong way to do it as long as you get the right answer. I'm going to show you my preferred method of laying it out. You do whatever suits you. Again, as long as it gets you the right answer. So in these sorts of questions, each bond, so a carbon to hydrogen bond, a bromine to bromine bond, they each have a different energy level associated with them. A different energy requirement for either breaking them or making them. What I like to do is make a list of what bonds I've got on each side. So I'm going to divide up my calculation area so I can deal with the left hand side and the right hand side separately. On the left hand side, I have got carbon to hydrogen bonds. I've got a bromine to bromine bond. Now I need to count up how many of each bond I have got. How many carbon to hydrogen bonds have I got? 1, 2, 3, 4. 4 carbon to hydrogen bonds. How many bromine to bromine? Just the 1. Carbon to hydrogen bond has got an energy association of 412 kilojoules per mole. Bromine has got 193 kilojoules per mole. Multiplying those together, 4 times the 412 is 1,648. The 1 times the 193, I didn't even need my calculator to do this one, is 193. Add those numbers together. Total energy required for breaking all of the bonds on the left hand side is 1,841 kilojoules per mole. I will just add here that that is for breaking. Now to deal with the right hand side. I'm just going to repeat the process that I did before again. I'm just going to have a look and see what bonds I've got. I've got a carbon attached to a hydrogen. I've got carbon attached to a bromine, and I've got a hydrogen attached to a bromine. And just like I did before, I'm just going to simply count up how many I've got. 1, 2, 3 carbons to hydrogens, 1 carbon to bromine, and 1 hydrogen to bromine. I do like crossing them out like that just because it makes sure that you've covered all of them rather than missing some out every now and again. Now my carbon to hydrogen we had before has an energy of 412 kilojoules per mole. The carbon to bromine we don't actually know. That's what we have been tasked with working out. So actually I'm just going to put a big old X there, just like we do for solving algebraic equations in maths. My hydrogen to bromine, 366 kilojoules per mole. Just like we did before, I'm going to multiply those up. 3 times 412 is 1,236. 1 times x is simply just x. And 1 times 366 is 366. So if we add all those together, you get 1,602 plus the x. I haven't been able to deal with that x yet. I'm just going to leave it there. And that is the energy required for bond making. So making all of those bonds from new. It has given us that the overall energy change associated with this process is minus 51 kilojoules per mole. So the bond breaking minus the bond making will give me minus 51. Let's put that down as an equation here. Now we have got just a very simple algebraic rearrangement to have. If you're doing well in GCSE maths, this should be really easy. All that we need to do is get the x by itself. I'm going to start just by very simply doing this calculation. So if I do 1,841 minus the 1,602, I will get 239 plus x still equals minus 51. I still need to get x by itself. Got minus 51 over here, plus 239. To get rid of a plus 239, I need to minus 239. If I minus 239 on this side, I am left simply with x. Whatever I do to one side, I've got to do to the other. So I'm minus 239 there to get myself minus 290 kilojoules per mole. And that is the bond energy of the carbon to bromine bond. 4 marks, relatively easily gained. As previously stated, you can do calculations in a number of different ways, and therefore it can be tricky to mark these as an examiner. But what examiners will be looking for are a few key points as we go through. So the marking points here would be, your first mark is for seeing this number here, okay, that you have calculated the energy required for bond breaking. The second mark is for calculating the energy required for bond making. The third mark is for applying all this in an equation, linking the bond breaking, bond making, the unknown bond energy, and the overall energy change. Third mark for popping all of that into equation. And the fourth mark for getting to that final stage. If at any point you have gone wrong, let's say you've only done 3 lots of the carbon to hydrogen bond, therefore got a wrong number here and wrong number here, you will still get what is called an error carried forward mark. So you might lose this first mark, but you would still get the 3 consequent marks. That is how you work out a bond energy calculation. There are alternative methods. One method also taught by teachers is to only use the bonds that actually change. For example, these 3 bonds here, the carbon to hydrogen bonds, don't change because they are there and there. So they would only work out some of the bonds that are changed. This works for some people, and if that works for you, absolutely awesome. I tend to forget bonds if I do it that way, so I prefer this methodology. That's all for now. More videos will be coming soon on more exam questions, including calculations. Keep your eyes peeled. Bye-bye.